So here's a method of joints problem. When it comes to method of joints, we have to break down our structure into individual points and draw free body diagrams for each of those points to solve for unknowns, and kind of work your way down the line until all your required unknowns are solved for. So the way I do it is I initially just kind of evaluate the structure and determine what my overall unknowns are. And then you can see here we have this large truss system, and we have a support here and a support here. And then if we take a look at what this problem asks for, it says determine the force in numbers AB, AC, BC, and DB. So I just kind of go back to this picture and see what exactly those forces are. So we have a force here, AB, then AC, and then BC, and then BD. So then now I can kind of formulate a game plan. So taking a look at this, initially you'd probably think that you would need to solve for these supports, but if you were to take point A and draw a free body diagram there, you notice that the support is a non-issue. And then if you were to take point B as your second point and draw a free body diagram there, you notice also that both these supports will not be a problem. So you can individually draw free body diagrams at each of these points without having to worry about solving for these unknowns at the mounts. So then knowing that probably it'd be best to work left to right so that you can at least solve one of these unknowns for point B. So we're going to start by drawing a free body diagram at point A. So we come down here, this is what this is. So at point A, you're going to have a force coming out at this AB section, and then you'll have another force coming down here for AC, which is up here. And take note that I used the triangle method for our angle, and because our dimensions, it's just a 3, 4, and then a 5 for our hypotenuse. So instead of using cosine or sine to try and figure out that angle, we can just use this triangle for our calculations. Now when it comes to drawing your free body diagrams on these unknown forces, you can either draw them in tension, which is when the force is going away from the point, like I have it drawn here, or you can draw them in compression as well. Whenever in doubt, just draw in tension, and then if you have a negative value as your answer, then you know that that force prediction was wrong, and it'll just be the opposite of whatever you guessed. So now that we have a free body diagram drawn for point A, we can kind of determine like what would be the best method to solve for this, whether we should take a moment around a point or just use a summation of forces of X and Y. Now if you see in the Y direction here, you only have one unknown, and then you're also have a given. So we could pretty much solve for AC fairly easily by just doing the summation of forces in the Y direction. And then after you solve that, then AB will be pretty standard, because then we can just do the summation of forces in the X direction and solve for the last variable for point A. So then after that, after we've calculated all that, we repeat these steps as necessary. So once again, we'd have to draw a free body diagram for point B, and then calculate and determine what's the best course of action to calculate the unknowns for point B. So let's do the calculations for point A here first. Alright, so since I already kind of went over what would be the best method, we don't have to take a moment around a point or anything like that. We can do everything with the summation of forces, but we do need to do the Y direction first to solve for AC. So we're going to go ahead and say this is Y in the positive direction, and then a summation of forces in the Y direction, and that'll be equal to. So both of these values over here are going into the negative y direction using our axis that we determine for our free body diagram. So force 1, this force is going down to 130 pounds, and then AC is also in the negative. So we'll start with AC first, and since I'm using the triangle method on these, how I do that is you find the y direction on your triangle, and then you divide it by the hypotenuse. So in this case, it'll be a negative 4/5, and then you multiply that by AC, and then for the 130 pound value, same thing, you have a y value of 12, so then you'll divide that by the hypotenuse, so minus 12/13 times 130. That's going to equal to 0. Now we can just isolate our variable to one side and then solve. So we end up getting a 4/5 AC is equal to negative 12/13 times 130. And then AC ends up being a negative value. AC is equal to negative 150 pounds. Now, since this is a negative value, we know that our prediction here that it was in tension is incorrect. So AC is equal to 150 pounds, and that's going to be in compression. Now, for the x direction, we have everything solved for, so we'll just go ahead and plug in. So going to the positive right direction, summation of forces in the x direction. So we'll just start with our unknown variable. It's a positive value. It's going to be AB plus, it's going to be minus, and then for here we'll use the x value in our triangle, which is 5, and then divide that by the hypotenuse, and then multiply that by the 130. So minus 5/13 times 130. And now for AC. Now, since it was in compression, we drew it in tension, so we have to maintain that value. So initially, when we calculate it while it was in tension, it's a negative value. So we're going to still use the negative. So that'll be negative, and then over here, our x in the triangle is 3, and then divide that by 5. So negative 3/5 times 150, and that's equal to 0. And then that gives us a value of 140 pounds in tension. So now that point A is all solved for, we can go ahead and move on to point B. So just evaluating point point B, we already have this force solved for, and then so pretty much all we have to solve for is point BD, which is pretty straightforward, because if you look at the force going towards the BC direction, there is no other force in the y direction, so you already know that's going to equal to 0. So for point B, We'll start off with a force in the x direction. Now, since our AB value was 140 pounds in tension, we still drew it as tension here, but it's going in the negative x direction. So we're going to have to make this value negative 140. Now BD is going in the positive x direction, so we'll just add BD, and that's equal to 0. So BD is equal to 140 pounds. Since it's a positive, it's in tension. Now for the pretty straightforward y direction. Essentially just negative BC is equal to 0, and then BC is just equal to 0. So that's pretty much it. Main thing is to, once again, just evaluate this original drawing here. Determine whether or not you need to solve for these initial mounts. Sometimes you will. Sometimes you have to do a free body diagram for the entire structure, solve for whatever the mounts, the unknown forces in the mounts, and then you can individually start solving for the points. But here that wasn't required, and then once you determine which points are your unknowns, then you can start working, like in this case, left to right, to solve from point A by drawing free body diagrams at each individual point. And then once you have these free body diagrams, you can just use our standard summation of forces equations and solve for all the variables one at a time.